In this video, I'm going to demonstrate how you're going to enter your data into Excel in order to determine the average volume of water measured by a particular device and its standard deviation. The first thing we're going to do is we're going to identify exactly what device we use to measure the water. So for example, let's say we used the 50 ml graduated cylinder to measure out 25 milliliters of water. Now, the next thing in line 2, we're going to develop our labels. So you have trial 1, or you have the trial in column A2. In cell B2, we need to identify the fact that we used an Erlenmeyer flask. So we're going to type in the mass of the empty Erlenmeyer in grams. And we're going to go ahead and expand column B so that it fits that label, so that we can see that label clearly. In cell C2, we're going to label that we are going to be determining the mass of the Erlenmeyer plus the water in grams. And again, we're going to expand this so that it fills up, so that we can see the entire label. The next column will be, we will type into cell D2 the fact that we want the mass of water in grams. And again, we're going to clean this up so that we can see what we're dealing with. Now, the next column is where my information is going to differ slightly from what was shown in the laboratory, because in column E, specifically in cell E2, we're going to put the density of water. And that is dependent upon our degrees Celsius. Column F, cell F2, we are going to type in the actual volume of water, and that is going to be in milliliters. Now we have our columns set up. Now what we need to do is type in our data. So we did 3 trials. Let's say in trial 1, the mass of the empty Erlenmeyer flask was 84.623. Once we added water, that mass became 109.653. And let's go ahead and put in our data for each of these. So in column B, cell 4B, we would type in the mass for our second empty Erlenmeyer flask, which was 84.624. And the mass with the water was 109.754. And then we do the same thing for trial 3. So that's, let's say, 84.623 and 109.952. Now, we're going to create a formula in D3. And that formula, if you'll go up to your bar, you will type in the equal sign, and it will be C3 minus B3. And you hit enter, and it'll automatically do the calculation for you. Um, now, if you will highlight that particular cell, D3 again, you'll see a little square on the bottom right-hand side of the box. If you'll grab that square, you can pull that square down and it'll automatically copy into the next two cells so that you don't have to retype in the formula each time. Now, you go to look up your density. You find your density on the second document that was in your density lab folder. And in that, we find out at 24.3 degrees Celsius, which is my made up water temperature, the density is 0.997221. And we're going to unfortunately type that in multiple times. So 997221. Whoops. And of course, we've got to make sure it looks right. There we go. And now we have our density in each of those cells. Now we could have just simply copied and pasted that in. It's up to you how you want to do that. Now to get to your actual volume, if you calculate volume, volume is going to be the mass divided by the density. So we're going to, again, type in a formula. It's going to be equal to the mass, which is D3, divided by, which is your slash, and the density, E3. And you're going to hit the down arrow. And then again, you can drag and pull. Now, here is some things that we need to do to clean this up. First of all, when we're dealing with significant figures and we're dealing with subtraction, the number of decimal places that should exist will be the same as the measurement that had the fewest decimal places. So in column D, when we did subtraction, our decimal places has to be equivalent to the decimal places of the mass of the empty Erlenmeyer and the mass of the Erlenmeyer plus water. So we need this to be to 3 decimal places. So what you can do is you can highlight that, and then over here, you can there's a 0.00, which allows you to increase the number of decimal places. So you can click on that and it'll automatically increase it to the number that you need, which was 3. The same thing goes for the result in cell D4. We need 3 decimal places because both of the measurements had 3 decimal places. And so we're going to increase it to 1 more decimal place so that we have 3 decimal places. Now that also is associated with our volume of our water. When we do division, which is what we did to get the density of our, when we do division, which is what we did to get our volume of water, the result will have the same number of significant digits as the measurement with the fewest. Since the measurement with the fewest had 5 significant digits, our answer should be to 5 significant digits, which that means it would be to 3 decimals. So you can highlight that and then you can decrease the number of decimal places so that it only has 3 decimal places. Make sure I get this right. There we go. And that is how we'll clean up our table. Now, the goal of today is to figure out the average volume, and then to figure out the standard deviation. So in in cell E6, you will notice I typed in the word average volume. And in cell E7, I typed in standard deviation. Now, let's now we're going to work with formulas to get these two results. So for the first column, we have to get the average volume of our three volumes. So we're going to go in here and we're going to click on formula. You're going to click on insert function, and in the search bar, you'll type in average. And it'll give you an option, which will just take the regular average, and we're going to say insert function. Now it should highlight cells F3 through 5, but if it doesn't, then make sure those are highlighted, and then over in the right-hand column, click Done, and it'll automatically give you your average volume. Now to do our standard deviation, highlight cell F7, and up in the search bar, type in standard deviation. Or, well, sometimes it's just STDEV. And you will see an STDEV, and we're just going to use the STDEV and highlight the STDEV and say insert function. Now you'll notice it went through F6 this time, but we don't want to go through F6. We only want F3 through 5. So instead we're going to highlight F3 through 5 and hit enter. Or excuse me, hit done. And it'll calculate your standard deviation. You will notice that the standard deviation gives out this very long number, but when we're dealing with standard deviations, again, we only want one digit. So we're going to decrease this down to one digit in our standard deviation. And so that would be 0.2. So what that means is when I do my I report out the volume plus plus or minus the standard deviation. I would report out 25.2 plus or minus 0.2. And that is how you're going to create your table, and you'll do this 4 different times for each piece of glassware that you used. Now, what all does this mean? What you should see is that the type of glassware that you use is extremely important in the quality of the measurement that you're going to be able to obtain. I had a 0.2 standard deviation here. That meant it was 25.2, and I could go up to 25.4 or 25.0, and that would be within my range of for the graduated cylinder. Hopefully you'll see something like the burette be much more accurate.